Okay, in this lesson we're looking at strategies for solving polynomial equations. And the first method that we're going to be looking at is factoring. So looking at the first example, if I'm going to solve this equation by factoring on the left-hand side, the first thing I would do is take out a common factor of x. And that would leave me with x squared plus 8x plus 16, which could be further factored as x times x plus 4 times x plus 4. Once I have my equation in factored form, it becomes easier, because now I know that the only way the left side of this equation can equal 0 is if one of the factors is equal to 0. Basically, when I multiply a series of numbers together, the only way I'm going to get 0 as an answer is if one of those numbers was 0 to begin with. So now my two solutions become x equals 0 or x plus 4 equals 0, in which case x equals negative 4. So those are the two solutions to this equation. Now graphically what that means is those are the x-intercepts. So on the graph of the associated function, I would put my intercepts at 0 and negative 4. Now bearing in mind that this is a cubic function with a positive leading coefficient, I know and the x equals negative 4 is a double root. Let's make note of that as well. So because of those factors, we know that this equation looks, or graph, sorry, looks something like this. Now the next example, when we said about factoring on the left-hand side, now there is no common factor, so we look for another alternative. We can factor this as a simple trinomial because the coefficient of the leading coefficient, I should say, is a 1. So we need to find two numbers that have a sum of negative 5 and a product of 4. And those two numbers would be negative 4 and negative 1. Now the only thing that's a little bit different here is the fact that the exponent on the first term is a 4, not 2. So when you break this down into its brackets, it will actually be x squared minus 4 and x squared minus 1. So that when you would multiply that back out, you would have x squared times x squared, which is x equals 104, and so on. Now, each of those brackets can be factored further. So x squared minus 4 and x squared minus 1 are both differences of squares. So now I can factor this as x minus 2 times x plus 2 and x minus 1 times x plus 1. And now I know that one of those factors is equal to 0. So if x minus 2 equals 0, we know x would be 2, so there's one solution. If x plus 2 is 0, x is negative 2. If x minus 1 is 0, x is 1. And if x plus 1 is 0, x is negative 1. So marking off our intercepts at negative 2, negative 1, 1, and 2, I would then find the y-intercept. So when x equals 0, y will equal 0 to the exponent of 4 minus 5 times 0 squared plus 4. So the y-intercept, the y-intercept will be 4, which gives us sort of a better idea of what this graph will look like. So it's a quartic function, and it opens up. So the end behavior is going to be quadrant 2 to quadrant 1, all single roots. So your graph is going to look like so. So when you have the graph, the solutions to the corresponding polynomial equation are the x-intercepts. So therefore, if we have an equation that's more difficult to factor, such as this next example, both of the ones in this next example, we could actually use graphing technology to find the roots. So the strategy we're going to use here is to graph the polynomials on the left-hand side, and find the x-intercepts. Now, in order to find the x-intercepts, you are going to press, once you've got the function entered, you'll press second trace, and I believe it's option 2 you need to find the zeros. And then there's a bit of a procedure you have to go through to set the boundaries to direct the calculator to find the appropriate x-intercept. So I think it would be easiest for you at this point to ask me for some help when we're in the classroom, and I'll show you how to use the graphing calculator to find the x-intercepts. So aside from that, that concludes this lesson.